Hello, geometry students. Just wanted to put together a quick little how-to video on reminding us how to use trig to find angles. So first of all, let's take a look at a right triangle. And on this triangle, let's say this side is 4, this side is 10, and we're wanting to find this angle here, x. Our first step is to write our SOHCAHTOA at the top of our paper. Next step is to identify the angle that we know, or angle that's we're wanting to find, and that's x. That helps us identify our O and A in this triangle. The 4 is the dimension that's right next to or adjacent to the x, so I'll put an A for that one. The 10 is directly across from the right angle. Directly across from the right angle is always our hypotenuse. It's always the longest side. It's always the one that will be next to our angle, but not opposite of it or adjacent to it. So we have A and H. Now we go back and look again at our trig ratio up above, and you'll see that A and H is a cosine. So let's go ahead and write this trig ratio. The cosine, oops, got to spell that correctly, sorry. Cosine of our angle x equals A, which is 4, over 10, our hypotenuse. Now, unlike the previous ones where we used trig to find the length of the side, and we set this as a ratio and did cross multiply and dividing, this is not going to be solved that way. This is only solved by undoing this trig ratio or trig function on the x. To do that, we're going to use something called the inverse or arc cosine of the ratio 4/10. Now, that's something that is done with our calculator. And so, first thing I want to do is take a look at our calculator, remind you that we do have to go to mode and make sure that we're in degrees. It's going to stay in degrees. If you set it in degrees, it will stay there, but if you do turn your calculator, or excuse me, you change the batteries in your calculator or it dies, it will default to radians and not give us the answer that we're looking for. So, now we're ready to put this in our calculator. You'll see above each one of my trig ratio functions, the sine, cosine, and tangent are the inverse functions. They're shown with sine to the negative first power is what it looks like, cosine to the negative first power, and tangent to the negative first power. And that's not what it's indicating. It's indicating that those are the inverse or arc functions to the original ones. So to undo a cosine, what we're going to do is press our second button and then cosine. You'll see that our screen looks exactly like what I have written here, and then we'll just simply enter in the ratio of 4/10. Press enter, and we get x equals 66.4218215. In Delta Math, they're asking us to round it to the nearest degree. So the 6 is the nearest degree. We'll take a look at the next number to the right, the 4. And since 4 is less than 5, this will round to 66 degrees. And that's our answer. Let's try one more quick one just to make sure we have this solidified and understand. I'll go ahead and draw another right triangle. I'll use this as my angle that I'm looking for. In this case, let's say this side here is 5.3, and this side here is 7.2. Steps again start with recognizing that we're going to have to use the trig ratios, so ka or toa. Next, we'll identify the angle that we know. In this case, the angle is the x, and we're going to look at the side that's right next to it or adjacent to it. In this case, it is 7.2, so that is our adjacent side. Directly across from our angle this time is the opposite side. 5.3 is opposite. Now I'm going to look at my ratios and look for which one has O and A in it. In this case, it is the tangent. Notice I didn't bother with putting an H on here because I don't know what this side is, nor do I need to know what that is in order to find x. O and A gives us the tangent of x will equal the opposite, 5.3, divided by the adjacent, 7.2. Like we did before, in order to solve for x, we're going to have to use the inverse or arc tangent of this ratio, 5.3 divided by 7.2. I'll go to my calculator, press second tangent. You'll see that we have now the inverse or arc tangent, and then simply enter in, like we did before, the ratio as it appears. Do want to point out in both of these the smaller number is on top, but that isn't the rule that must be done. Okay? Sometimes we'll get a value with tangents where the numerator will be larger than the denominator. Sometimes in this case the numerator will be less than the denominator. Our sines and cosines will always have the larger number in the denominator because sine and cosine, as you can see from our SO, CA, and TOA, have h as the denominator. H always has to be the longest side in the right triangle, so therefore the larger number is always going to appear there, but not necessarily the case with our tangent. So that was just a quick little side note for you. But you'll see, again, I just go ahead and press enter. The value of 36.3571972 is given on the calculator. Round this to the nearest degree. Using the 3, that would give us just 36 degrees for our angle. Hopefully this is helpful to you, and this brings back to memory how to find angles using trig. Have a nice day.